Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9, which is the final question from the January 2024 Pure Mathematics P4 paper from the International A-Level Edexcel exam. This question here is about parametric equations, and we're told first that figure 4 shows a sketch of a curve C, which has a parametric equations given x equals secant t and y equals root 3 tan times t plus pi over 3, where t is between pi over 6 and pi over 2. So we got to first find dy dx in terms of t, right? So we want to find what dy dx is, but we want to find it in terms of t. So what we don't do here is we don't make the Cartesian form of the equation, which I think we have to do later on anyway, because finding the Cartesian form where it's y in terms of x won't give us dy dx in terms of t. We need to use parametric, methods of differentiation in order to find dy dx in terms of t. Okay, so what we're going to do is we're going to use the chain rule. So we know that dy dx would be the same as dy dt times the dt dx. You could also say dy dt divided by dx dt, same thing, right? So now we can find both of these. We can find dy dt, we can find dx dt, and dt dx is just the reciprocal of that. And we can then continue and use this chain rule. So we know that y is equal to the square root of 3 times the tangent of t plus pi over 3. So we want to find dy dt. Now, the differential of the tangent of an angle is something which you should know. It's going to be the secant squared of that same angle, but it's something that is in the formula sheet, which I've got an extract of from here. So in case you did forget, you could look at the formula sheet you've got, and you can see here, they've told us the differential of the tan of some function of x is equal to the differential of that function times secant squared of that. So the root 3 times tan of t plus root 3 is going to be given. The differential of that is going to be root 3 times the secant squared times secant squared of that same angle times the differential of what's inside here, which is just 1 anyway. So that won't change that. So that's dy dt. And we know that x is equal to, as they told us, secant t. Secant t. So dx dt, now the differential of the secant of an angle is equal to the secant of that angle times the tan of that angle. That's, again, another given result that we can just quote. You don't have to prove it. So this is going to be secant t times tan t, right? So that's the, differentials. I can get rid of that for now. I'll just cut it in case we need it again. All right, so that's going to help us now because we're going to use that in this. We have dy dx is equal to dy dt, okay, which is root 3 times the secant squared of t plus pi over 3 divided by, and then we're going to have secant t times tan t. Secant t times tan t. So that's dy dx, okay? Now, they didn't say for us to put it in any particular form. So my, advice is, my guess is that this would be perfectly fine to leave your answer in this form. Okay, there's no issue with you leaving with this form, no need to try to simplify it or anything. Okay, because it didn't mention anything about any form to write it in. It just mentioned find dy dx in terms of t, and we can stop right there. There's nothing that cancels out. Okay, and that should be fine. I mean, secant tan, this is 1 over cosine x, this is sine x over cosine x. We can't make it any simpler than that. That's perfectly good. So there's the answer to part A of the question. The only thing is we might need this answer in other parts of the question. So I'm going to take this, get rid of that first. I'm going to take this, copy it, and then we'll use it on the next page. Okay, if we need to use it. It says, find an equation for the tangent to C at the point where t equals pi over 3. Give your answer in the form y equals mx plus c, where m and c are constants. All right, so now, let me take the gradient. This is the gradient that we found. This is the equation of the curve. Okay, now the tangent to the curve is basically, the curve was drawn on the other page, no problem. The tangent is a straight line which touches the curve at a certain point and has the same gradient of the curve at that point. Okay, so when t equals pi over 3, we need to find, so the equation of the tangent is going to be a straight line, so we have to find the equation using two things. We need to find the gradient of the line, we need to find a point on the line. And both of those we can find using the fact that we know t equals pi over 3. So we can find the point on the line by replacing the t as pi over 3 in this equation. Now, that will be x equals secant of pi over 3, which is the same as 1 over cosine of pi over 3. Now, pi over 3 is 60 degrees, so it's going to be 1 over a half, which is going to be 2. So the x-coordinate is going to be 2 of that point, and we know that the y-coordinate is root 3 times the tangent of pi over 3 plus pi over 3, which is 2 pi over 3. So that's root 3 times the tangent of 2 pi over 3. Now, 2 pi over 3 is going to be in this quadrant over here. So the tan of 2 pi over 3 is going to be the same as tan of pi over 3, but negative. So you're going to have negative root 3. Now, what is the tan of pi over 3? We could use a calculator for this, but I'm going to not. This is pi over 3, which is like 60 degrees. This would be 2, this would be 1, this would be root 3. So the tangent of pi over 3 is going to be root 3 over 1, which is root 3. So you're going to have basically root 3 times minus root 3, which is minus 3. So we know the coordinates of the point, okay, that we're looking for is 2 and negative 3. All right. And we also know that the gradient is given by this. This will give us the gradient. So the gradient of the tangent, okay, the gradient of the tangent is given by using this formula. So you have root 3 times the secant squared of pi over 3 plus pi over 3 divided by secant of pi over 3 times the tangent of pi over 3. So let's sort out this little bit of a mess. So this is going to be, you can say root 3 times, I'll put it like this, 1 over, and this is like cosine of 2 pi over 3, and that's squared, divided by, this is 1 over cosine of pi over 3, okay, times tan of pi over 3. Okay, so what will this give us? So this is going to be root 3 times 1 over, now cosine of 2 pi over 3 is going to be like negative of cosine of pi over 3. So it's negative of cosine, this is negative of a half. So negative a half squared is going to be positive a quarter. So this is going to be 1 divided by 1/4, which is going to give you 4 over, and 1 over cosine 2 pi over 3 is minus, as we said, minus 1 over 2, because cosine of, no, it's going to be minus 1 over a half, so which is going to end up being minus 2. I'll just write it in this full form. That's 1 over minus a half, sorry. You have 1 over minus a half, okay, times, and you're going to have tan of pi over 3. As we mentioned, the tan of pi over 3 is opposite over adjacent, so it's going to be root 3 over 1. So it's root 3 times root 3. Okay, so this is going to be root 3 times 4, so it's 4 root 3 over, and you're going to have minus 2 root 3, which gives you minus 2. So the gradient of the tangent is negative 2. Let's see if I'm correct by the calculator. Okay, and let's see if we get the same answer, just to make sure. So we have root 3, and we're going to have times. Now remember, we can't write secant in the calculator, so I'm going to use 1 over. This is going to be, so this is going to be, this whole thing is going to be squared, right? So 1 over, whoops, that's going to be cosine of 2 pi over 3, cosine of 2 pi over 3, okay, and that's going to be squared, right? Divided by, you can say tan pi over 3, so I'll have another fraction here. So I'll have tan of pi over 3 over 3 divided by, that's going to be cosine of pi over 3. Let's see how this pans out now. Right, make sure that we are in radian mode. Press equals, and I've done something syntax here. What have I done? What did I do here? I forgot to close this bracket. Hopefully this will work now. Yes. I got -2. And this says 2. Did that work out to be 2? All right, see, I made a mistake somewhere. Where did I make a mistake? Let's go back to see. Okay, this is √3 times, that's going to be positive for sure, right? That's going to be positive because you've got wherever it's going to come out, it's going to be negative, it's going to be squared, right? So that's √3 times 1 over a quarter, okay? So that's going to be 4√3. And then we have 1 over cosine of pi over 3. Oh, it's not 2 pi over 3. No wonder. That's my mistake. Okay, so I've gone back and corrected my mistake. I've said this is cosine of pi over 3, not 2 pi over 3. So the cosine of pi over 3 is positive a half. So it's going to be 2√3. So 4√3 over 2√3, which is 2. Good. So it's always good to go and check your, your work and make sure I've checked with the calculator and made sure. So we've got the gradient of the tangent is equal to 2. So we know the point is 2, -3, and the gradient of the tangent is equal to 2. So now we can find the equation in the form y equals mx plus c. So we have y minus y1 equals m times x minus x1. So y minus -3, which is y plus 3, equals m, which is 2, times x minus 2. So you have y plus 3 equals 2x minus 4. So you're going to subtract 1 from both sides. So y equals 2x minus 4 minus 3 from both sides. So it's -7. Y equals 2x minus 7. And there is the answer to this question, part B. Right? So you have to just be careful entering these values in. Okay, I made a silly mistake here. I took this as cosine of 2 pi over 3 when it's supposed to be cosine of pi over 3. So that's why my sign was different. But I checked in the end to make sure, which you should always try to do in case you make a silly mistake like that. In fact, we could have just put it in the exam. I would have probably just stuck in the calculator from the beginning. And, I just did a bit of mental stuff here. That's no problem. So now that's the end of question number 9, part B. I think there's a part C. Yep. And is there a part D? No. Okay, so part C, this is the last part of the last question in this paper. Now, it looks a bit daunting, 5 marks, but it's actually quite doable. But in an exam conditions and the last question, I'm sure people might have run out of time and stuff. You got to just keep your wits about you and try to relax and don't rush and don't panic and do everything methodically. Hopefully you will be able to have enough time in the exam to finish it and also check your answers. So that's how you should go into the exam, hopeful for that. So this last part of the question here, it says, show that all points on C satisfy this equation where a and b are constants to be found. So basically what they're telling us to do is to rewrite this in the form of a Cartesian form. Okay, if you rewrite it in Cartesian form, then that will be, you know, an equation where all points will satisfy this equation. Right, so now, how do I write this in Cartesian form? Well, what we can do is we're starting off with y equals the square root of 3 times the tangent of t plus pi over 3. Now, the first thing I see is, you know, what I want to do is I want to replace the secant t's with x, right? I want to replace secant t with x. I know that there is an identity that I can derive from sine squared t plus cosine squared t equals 1. If I divide everything by sine squared t, I'm left with, by cosine squared t, I'm left with tan squared t plus 1 equals secant squared t. So I know that if I can express things in terms of secant t, I can then replace things with x, right? However, I don't have the tan of t, I have the tan of t plus pi over 3. So I want to rewrite this in a form where I can split it up such that I have the tan of t. So that's where we can think about the addition formulae for tan of a plus minus b, which is a formula in our formula sheet, which I have taken an extract from here. We have the formulas for sine a plus b and cosine a plus b. Now, one of the students was mentioning that we never really use this, but here's a time to use it, although maybe it might not be so obvious in the beginning. So first, let's rewrite y in terms of this. So you have tan of a plus b. So in this case, our a is t and our b is pi over 3. So we'll have, this is going to become tan of a, so root 3 times, put in brackets, the tan of a, which is the tan of t. Okay, there's a plus here, so there's a plus here, plus the tan of b, which is the tan of pi over 3, which we can find its value, divided by, and we have 1, and it can be minus, when that's a plus, that's a minus, minus the tan of t times the tan of pi over 3. And as we mentioned before, the tan of pi over 3, this is like 60 degrees, that's 2, 1, that's root 3, sorry, that's 1. So the tan of pi over 3 is opposite of adjacent, which is root 3. So all of those will be root 3s, these tan of pi over 3. So y is going to be, that's the root 3 already there, times the tan of t plus root 3 over 1 minus, and you're going to have root 3 times the tan of t. Okay, so that's what y is equal to, all right? So we know that x is equal to secant of t. So now we're going to try to introduce this into here. So I know that, as we saw from this, that tan squared t plus 1 equals secant squared t. So I'm going to take this, and I'm going to rewrite this in a form such that I can replace the secant squared with x. So basically, I know that the tan squared of t plus 1 is equal to x squared. So I can replace secant t with x, that can give you x squared. So I can say tan squared of t is equal to x squared minus 1. So the tan of t is going to be the square root of x squared minus 1. Okay, so wherever I see tan of t, I can replace it with the square root of x squared minus 1. So I have y equals the square root of 3 times, and this is going to be the square root of x squared minus 1 plus root 3 over 1 minus root 3 times the square root of x squared minus 1. Okay, so we've got that far now. Okay, so now what do we need to do? I've just got this here to keep in mind how our answer should look at the end. We're kind of getting somewhere, all right? Now, if I multiply root 3 by this bracket, by this root, remember, I know that root of a times root of b is the same as the root of a times b, both under the square root. So if I multiply this by this, I can have the square root of 3 times x squared minus 1 plus, and the square root of 3 times the square root of 3 is going to give you 3, divided by, and here I'll have 1 minus, and the same thing, this will be 3 times x squared minus 1 underneath 1 squared bracket. Now, how does this become that? How does this become that? I can see I've got like 3x squared minus 3 under the square root. I've got some things there that might help me. Now, what I notice is that here I have a denominator which is not rational because you have a surd in it. So if you remember from P1, so go back all the way to P1, when we want to write something in the simplest form, in surd form, we multiply by the conjugate. So for example, if you have 1 plus root 3 in the denominator, we multiply both the numerator and the denominator by 1 minus root 3. So we'll do the same thing here. I'm going to multiply the denominator by 1 plus the square root of 3 times x squared minus 1. And I'll do the same for the numerator. Multiply all of this by 1 plus 3 times plus the square root of, 1 plus the square root of 3 times x squared minus 1. Okay, that should rationalize the denominator and hopefully give us something in this form. So we have y equals. So I'm going to multiply this by this. That's going to give me the square root of, I can expand the bracket so it looks like that. So 3x squared minus 3. That times that. Then this times this will give me plus 3 times x squared minus 1. So 3x squared minus 3. If I multiply these two together, the root will disappear. So I'll have 3x squared minus 3. Okay, and then I have 3 times 1, which is plus 3. And I have 3 times this, which is going to be 3 times the square root of 3x squared minus 1 over, long-winded here, multiplying these together, you have a difference of squares basically. So you'll basically have 1 minus and this whole thing squared. Now this whole thing squared is going to give you 3 times x squared minus 1. All right? So now let's see if this simplifies down to something that looks similar to this. So we have here y equals. We have these two disappear. So you've got your 3x squared. So I've got 3x squared. That's good. So the a is 3, looks like. And you've got these two, which are like terms. This is basically the same as that. So I can rewrite this as 3x squared minus 3. So it looks the same. This is 3x squared minus 3. So I have 3x squared minus 3 plus another 3 of those. That's plus 4 times the square root of 3x squared minus 3. So that looks correct. Over, and I have 1 minus 3x squared, okay, and minus 3 times minus 1, which is plus 3. Okay, plus 3. And that gives us exactly what we're looking for here. 4 minus 3x squared. So we can see, hopefully we're on the right tracks, and we did it. It worked. It looked like a bit daunting at the beginning, but just follow some logical steps and you get there in the end. So this is over 4 minus 3x squared. Having seen that work out exactly as it looks like we've done the right thing. Now it says here where a and b are constants to be found. So you just write it in this form. If you want to write, therefore a equals 3 and b equals 4, you can. But there is the answer to this last part of this last question on this this January 2024 paper from Edexcel International A-Level. So we've completed the whole paper. I don't think there's a part D, no. Let's make sure that's the first question is worth how many marks? The first question is worth 3, that's 3. The second question is worth 4, that's 7. And the last part is worth 5, that's 12 marks. Let's have a look. Page 12 marks, yes. So that's all the questions we know for sure. So therefore, we have finished this paper. Thank you for watching. I hope you enjoyed. I hope you learned some tricks and you learned some, of the principles that we need to know to answer such papers. Now, other questions from this particular paper will be found in the playlist that appears at the top right of the screen. At the end of the video, other questions from this topic of parametric equations. And this one is one where it includes converting from parametric to Cartesian form, which doesn't come up that often, but this was a pretty difficult one, actually, to be honest with you. This was a very challenging one, but we got there in the end. And if you'd like to subscribe to the channel, click on this link. And if you want to find out how to use my channel to find things that you might be looking for, you can watch the video that will be linked at the top here. Thank you for watching and see you soon.